Talk about ratios. Ratios are comparing two quantities or two objects. For example, you have 3 squares and you have 6 circles. If I ask you to find a ratio of squares to circles, can you compare the two numbers? Let's start with squares. How many squares do you see? I see 3 squares. How many circles do you see? I see 6 circles. So we can say there are 3 squares to 6 circles. That's one way of saying it. Another way to say it is write it as a fraction. You know, it's two numbers. So you can say there are 3 squares to over 6 circles. And the last way of saying it is 3 squares colon to 6 circles. All 3 examples mean the exact same thing. They're all equivalent. 3 squares to 6 circle is the same as 3 squares over 6 circles, which is the same as 3 square colon 6 circles. But let's go back to our ratio of a fraction. Can you simplify this? I think you can. What is the greatest factor that goes into 3 and 6? 3. So it's 1 square to 2 circles. Do you see how I label it? We do not want naked numbers, because I know your science teachers have talked about that. We want all our numbers to be labeled with units. So our next example is circles to squares. Order does matter when you do ratio. So let's see, how many circles do you see? I see 6 circles. To how many squares do you see? I see 3 squares. So that is a ratio. But let's write it as a fraction. You have 6 circles to 3 squares. Can you simplify this? Yes, you can simplify this. What is the greatest factor that you can divide both of these numbers by? You can divide both numbers by 3. So it is equivalent to 2 circles to 1 square. But you're going to say, isn't that the same thing as the other one we just did? No. This was a find a ratio of squares to circles. The second example says find a ratio of circles to square. Completely different. Order matters. So let's see if this really is true. Are there really 1 square to every 2 circle? 1 square, 2 circle. 1 square, 2 circle. 1 square, 2 circle. It does work. 2 circles to 1 square. 2 circles to 1 square. 2 circles to 1 square. So again, we are comparing 2 different items. Our next one is find a ratio of squares to total shapes. Whoops, forgot this. Squares to total shape. So how many squares do you see? I see 3 squares to the total shapes. 1, 2, 3, 4, 5, 6, 7, 8. 9 shapes. Can you write this as a fraction? I see 3 squares to 9 shapes. Can you simplify this? Yeah, you can simplify it. What is the greatest factor that goes into 3 and 9? 3. So it is 1 square to 3 shapes. So 3 squares to 9 shapes is equivalent to 1 square is 3 shapes. So it's the same as. So let's see, is that really true? Is there 1 square to every 3 shape? 1 square, 3 shape. 1 square, every 3 shape. 1 square to every 3 shape. It is true. 1 square, 3 shapes. 1 square, 3 shapes. 1 square, 3 shapes. So it is true. Order matters. Let's make it a little harder. What do you have? Circles to total shapes. How many circles do you see here? I see 6 circles to how many shapes? 9 shapes. Let's write it as a fraction. 6 circles to 9 shapes. Can you simplify this? What is the greatest factor that goes into this? 3. So it simplifies to 2 circles to 3 shapes. So 6 circles to 9 shapes is the same as 2 circles to 3 shapes. Let's see, is that really true? Are there 2 circles for every 3 shapes? 2 circles for every 3 shapes, 2 circles for every 3 shapes. It is. So when you do ratio, order matters. It's very, very important that you follow the quantity, what it states on the question. So it says square is a circle. You need to do square is a circle or circle is a square. If you do it backward, you will get it wrong. Also, it's very important that you label the units. Do not leave it as naked numbers. And sometimes ratios can be simplified. Not all the time, but actually most of the time it will be able to simplify. So that is the study of ratios.